Hello, everyone, and thanks so much for joining us live from the Research Triangle Park in beautiful North Carolina. And welcome to the latest DZone webinar. My name is Jason Cockrum, and I'm the Community Engagement Manager here at DZone. And we're really excited that you joined us today. It's a really great topic, and so we're glad that you joined us. If you're new to DZone, we are one of the world's largest online communities of software developers and experts. We publish all sorts of knowledge resources for developers and really anyone passionate about software development. We've got all kinds of things like ref cards, trend reports, and thousands of articles written and published by our community. And all this kind of makes us the go-to knowledge hub for software developers all over the world. We also do a ton of great events like this one today, and you can find them all at dzone.com/events. We've got things like fireside chats, virtual roundtables, and who knows, you might even see us in person at some events later this year. So be sure to check out dzone.com/events for all that information. Joining me today from beautiful Helsinki, Finland, we have Heikki Nusainen. I hope I got that right, but probably not. And then out in California, we have Murali Magdana Gopal. Heikki is the CTO and co-founder at Aiven, a managed cloud services provider for open source data managed technologies. He has over 2 decades of software engineering and information security expertise, and he's passionate about developer productivity, open source and open standards, and data management at scale. Murali is a cloud, AI, and analytics enterprise architect for Intel. He's an accomplished product and solution specialist with over 20 years of experience in evaluating and implementing new technologies, building strategic partnerships, product management, competitive analysis across AI, graphics, workstations, high-performance computing, and gaming segments. So clearly he's an expert. Be sure to pick his brain later on about some of that stuff. And the question for us today is, why are so many companies adopting an event-driven architecture? What are the perks? What are the benefits? What's the motivation for doing this? And some of the pitfalls that you may experience when moving away from batch to real time. So Heikki and Murali are going to spend a few minutes talking about that, and then we'll have some time at the end to answer any questions you might have. DZone is all about community, so we encourage you to get involved and to get engaged in the conversation. On the right-hand side of your screen, there's the box where you can chat with some of the other attendees and talk about what's being discussed in the presentation. And there's also a place where you can submit questions to Heikki and Murali, and we'll do our best to answer them, as many of them as we can, towards the end. And at this point, I'm going to stop talking and turn it over to Heikki. Heikki, take it away.
All right. Thank you, Jason, and thank you, everyone, for joining us today. So my name is indeed Heikki Nousiainen. I'm a CTO and co-founder at Aiven. I'm just, as mentioned earlier in brief, Aiven is a managed service provider, software as a service provider for open source data technology, data infrastructure on public cloud. And maybe kind of as a link to event streaming platforms, Apache Kafka is one of the technologies that we try to make easily available in the developer's hand. Today, we are looking at event streaming architectures, a little bit on what they are for context, and then looking on some of the benefits, some of the things that you should note, and then we'll look at a little bit from the architecture side on things that you should take into consideration when evaluating these technologies. But with that, I suppose let's dive right in. When I look at event streaming is a paradigm that aims to really provide an efficient way to ingest, process, and analyze a wealth of volumes of data in real-time manner. I think it's kind of as a part of the evolutionary step, it comes from the or follows the map reduce and batch processing that saw its boom in 2000s, and it's kind of evolutionary and realizing that maybe that map reduce and batch processing that really helped us to first capture and process the volumes of say web analytics or figuring out who linked to our pages, doing attributions to search engines, doing these transforms from web pages to links and vice versa. All of a sudden we were dealing with data volumes that we just couldn't readily handle with the existing database infrastructure. So we had MapReduce was found from there. And I see that event streaming is kind of continuation of that same trend. We are now having volumes of data and a new requirement on real-time ability to process that data that really doesn't perhaps anymore work with the MapReduce and batch processing framework. We had some efforts on tuning that effort by micro batching, but still, when the volumes of data grows to where we are kind of expected to process nowadays, we spend a lot of time on just scheduling, and kind of isn't exactly a perfect fit. And same with message queues. I think quite a clear precursor for event streaming. Messages working again on event level, trying to meet that close to real-time processing capability. Have some of the same kind of models on working with events and passing them around and building rich pipelines, but just the kind of amount of scheduling and amount of work that goes into handling things like message delivery, ensuring that the messages are not dropped, or how they are handled if there's any faults. The queue model, maybe again not the best fit after all. And event stream coming from this heritage, I think it uses a lot of ways on modeling how to deal with this volume of data and these requirements, that really focuses on how we can solve that technical problem. And that's what we have as of today. I will a little bit talk about the benefits, and then we can dig in a little bit into model on event streaming platforms. Just to cover a little bit of the use cases, or most common use cases, capturing say those web analytics logs, processing those at the scale where we're operating today, to any types of events that we want to capture from, be it capturing a customer order when they're making a purchasing, and making sure that we process that order all the way through dispatching and in the hands of the customer, or IoT, capturing telemetry, capturing say temperatures readings, and driving those through, and maybe through those we can do things like predictive maintenance, if you will, maybe not from temperatures alone, but in general, for the context on what we can do with event streaming platforms. If we look at the benefits of the event streaming, what I really see as the core benefit is the overall model, that the focus on excelling the delivery of single event as fast as possible through the pipelines, creating this endless stream of events that we generate on the other end, that we can process, that we can push to different pipelines, we can transfer, we can mutate, we can act upon. So really perfecting that kind of a workload that is actually quite common in how do we operate as of today. To really, the power comes from that at the ingestion phase, for example, ensuring that we have captured that message, and that's all the promises that we make at this point. Then to the processing, making sure that we can create maybe stage approach or stepped approaches, or distinct processing steps that can work in isolation, but then form very strong pipelines for processing of data and yielding results in real time. Being able to branch or split those streams into multiple events. Maybe when I want to deal with that order in two different branches, one for the dispatching and fulfilling that order, one for invoicing the customer in the end, or audit for that matter. Being able to enrich and transform those messages as they go. So getting an event from a device on the field and enriching it perhaps with the customer profile coming from a more traditional relational database. So that pipeline of events and those streams of events and working on the data in the flow is something where that has kind of where what defines event streaming, and also what makes it very, very powerful. Then from operational aspect, being able to split those processing streams or processing pipelines in independent steps, that allows us to scale them on demand. So maybe there's a one step of the process where we do calls or that are expensive, and we need more processing power. Then we can distribute or widen the pipeline for that individual step. Or then if we have some quick validations, those maybe we can run on smaller compute capacity. So having the ability to scale and adjust each of the step in the pipeline is something that where these streaming architectures or event streaming architectures excel over, say, maybe monolithic or traditional REST-based, push-based models. I also look at from coming from architecture side, I also look at it as a productivity measure. So having those independent processing steps as independent or having independent life cycle, reducing dependencies, having the ability to do independent development cycles on those each steps helps them organizations to move fast and brings them ability to innovate and excel and develop things fast. Being able to split those existing streams into multiple different use cases, reusing existing data assets as they go on, or even running in parallel versions. If we are about to create a new version, we can easily run, say, A and B testing and verify that the results from the new pipeline match the expected, match the existing before we perhaps promote that into production. So a very strong and powerful platform or paradigm that helps us to solve a lot of business problems, a lot of technology problems that allow us or the organizations that rely on event streaming platforms to excel at volume and in a real-time manner. Maybe coming then from the other side, looking at things that based on our experience on running quite a lot of our own operations on top of event streaming model and working with our customer base on of things or challenges that we would perhaps note here, worth checking. Event streaming platforms and event streaming paradigm itself, I don't think it's one tool that solves all the problems. It's not definitely a long-term storage. It's best paired with, say, maybe those traditional relational databases or data warehouses or object storages or dashboards in the back that allow us to then take the result but still keep the pipeline as efficient as possible. So there are two things. One is that in the stream model, it's quite costly, or it's quite inefficient to do random searches or random access to find a single event. So you get that stream, maybe you can look at what happened yesterday, but it's really not very efficient to find a single event if you need to look that up for any reason. So definitely important and very powerful tool, but one technology in the mix of what you need to build kind of modern applications of today. A second kind of thing worth noting is that while the streaming platform is definitely optimized for efficiency on delivering those messages, it's not necessarily best fit for then transferring very large items, maybe images or videos. That kind of content is best left perhaps outside the pipelines. One technology there we can use is commonly called dehydration. So taking the large binary blob out of the perhaps message, storing that in object storage and creating a reference or having a link in that message that allows us then to fetch and process the original item if we need, but still keep the message in a kind of smallest size that then helps to drive the pipeline more efficiently. And then, of course, when we're looking at a little bit of different model, we need to take care of data governance, access control. We at Aiven view we view this as a kind of it's a little bit of a challenge. It's a different model versus traditional databases, but at the same time, it's an extremely powerful and extreme, really good opportunity to really reuse those data assets that the organization is already having, creating new innovation on the streams of the data that we already process and handle. One other aspect of the data governance is schema management and management of the perhaps validation of the data or catalog of the data. In event streaming, we would definitely recommend moving into from a kind of message type style of schema into message type and message version schema. So having the ability to deal with multiple different versions of similar messages would allow us to do evolution and still maintain compatibility of those messages. So if we maybe look back at that IoT use case where the device is sending environmental information, maybe the next version of our device has additional sensors that allow us to uh, uh, measure the environment in a different manner. Having ability to detect and then adjust and maybe transform or backfill the missing information from other sources is an extremely powerful capability. And especially true if we ever want to roll back or reprocess the events again, then we might have this mix of different versions. Not a big challenge when you start to think about it from the beginning, but definitely something that we want to raise on the things of note list with event streaming. Now, when I look at technology selection or solution selection overall, there's always two things on top of my list. One is just simply, is this the right technology for the business problem or the technology problem at hand? Too often we have our favorite tools and we want to apply them to all different problems out there. And while streaming platforms and streaming architectures are extremely powerful, they're not always the best fit for everything. So be mindful here that it's not one size fits for all. It's a very powerful tool. Make sure that it's the right tool for the problem. And the second one is goes on to how quickly can we get our developers productive on this new technology, and what's the kind of return on investment on learning new technologies, learning new tools, and learning best ways to do it. Or then if we're looking at the operation side, on how to perfect operating the platform so that we are not spending too many resources on running the infrastructure itself. I will shamelessly borrow a couple of measures here that have been presented by my colleague David, but hopefully I'll do them justice. And the first one is the Alice and Bob versus Stack Overflow factor, and this is essentially if we ever having a challenge with the technology, how likely it is that we can find the solutions from existing resources, be it in this case Stack Overflow or Google or the community documentation, versus how well this is hidden within some specific persons, Alan and Bob in this case, that worked on the platform 2, 3, 4 years ago. So really spending or kind of evaluating also the available resources and how commonly the technology has been fielded and how commonly it has been used. Second factor to the same extent is by David's function of GitHub of technology, looking at how commonly these technologies are referred in GitHub projects, or how many tools are building on these specific technologies that we are evaluating, how many contributors there are from companies or as individuals, on how healthy the overall ecosystem is. And that's a good metric when we try to assess also on when we need additional talent to scale and grow our operations, or then vice versa, if we hit a problem, how likely it is that we can find someone to help us through that. Build and buy options also important. I think it's equally important that the organizations have the ability to run these technologies themselves if there would be a business reason to do so. So looking at, for example, the tooling around deployment, monitoring, the overall maturity of those. And then looking also at the options on what if we buy this as a service? Are there providers? Is there one provider or are there multiple provider? What's the healthiness of that technology in that axis as well? Making sure that we have ample opportunity as we're not tying us to a single perhaps vendor or single technology going forward. A business continuity measure as much as giving us the business business agility to run as we best see fit. I mentioned integrations and tooling. That's really important. And look at how healthy is the environment in that self. How easily we can integrate, especially streaming platforms. We quite commonly want to source events from an existing systems, existing databases, or existing ordering systems, or then sync the results into their data warehousing solutions, or somewhere we can actually use that information that we created for making business decisions or running our business processes. As an architect, I think it's also important to not only look at the good side scenario, but also look at what how do we deal with failure on understanding is that how critical these processing steps and how critical these pipelines are for our operations, so that we also understand the investment that we need to put in making sure that we have the right measures around and against any failures. So understanding how costly is the downtimes of the pipelines. For some use cases, this is mission critical, maybe it translates directly to missed revenue from customers that are not exactly waiting if there's any downtime on the ordering systems. Sometimes with if we are doing order fulfillment and a 1 hour downtime is not really critical if we can catch that up when we recover the systems. And same goes for what is then the value of messages, whether we or if we lose a single message or if we lose a bunch of messages, is it that each one of them equates to that one order, or whether that's something that is an IoT device that will just send the next update and we can recover from there without any consideration on the lost messages. So really understanding these values and then defining and documenting recovery time objectives, recovery point objectives on what do we expect, and then looking at the investment in context of those documented numbers. We at Aiven, we always say that resilience is better than prevention. So really looking at ways on how we can recover from all different types of failures and all different faults and get back to operation, rather than trying to or rather than overspending on trying to find out and analyze all the different ways and prevent on all the different ways how systems might fail. I like the model of defining or the model of crash-proof computing, if I got that right. So understand or building and architecting systems so that we always go through the recovery path, regardless whether we exited cleanly or whether we crashed. We always start by checking on where were we left off, and then reprocess from there if possible. And the benefit of that model is really that then we execute that recovery on or we have one code path to do both types of startups, and we execute also the recovery procedures on a regular cadence. But that being said, the streaming platforms and the kind of individual processing steps, they render themselves really well towards this model. So I've seen some really well architected full applications that build on top of event streaming applications, and regardless whether there are crashes or if even if there's bugs in some of the processing steps, we can remedy that bug and restart the processing from the point where we kind of have a last known good processing step, and then correct many issues on the field. So event stream platforms also are working really well in this regard. One thing need to say, implement or document a disaster recovery plan and make sure that it's tested regularly. On top of that, I'm a big fan of chaos monkey testing coming from Netflix, inducing errors into even the production pipelines to try to find ways how the pipeline will fail before it becomes critical and before it happens on a 4 o'clock on Sunday morning. Last slide before I hand it over to Murali from Intel and maybe discuss some of the things that Intel is working, and we're happy to be in partnership with Intel. But just a last slide on total cost of ownership. And for me, this is total cost of ownership should include also opportunity cost and the upside of things. So we are looking at, when we are selecting technologies and when we are selecting whether these are suitable for us, is this first, is this suitable for something that we wanna solve a business problem? What is the upside if we can handle this? How complex is the solution in respect of that upside? What is the expected return on investment on this investment? How can we help our developers to be productive from the day on of these platforms? Is there enough documentation or community support available? As well as how does this technology integrate um, the overall application landscape that we operate in? And then finally going into the decision on whether this is something that we want to consume as a service, or whether this is something that we wanna run on our own and manage. And then having that discussion on then how much talent is available to do that, how much effort is that operation if we do it, or how critical is this, that is it better to consume it as a service and have perhaps an external help to run it, operate it. But equally important, I think it's really important that the um community and alternatives are out there. So rather than having a single option, it's better to have those options and that freedom to make that choice over and over again if business reasons would so warrant. Well, thank you. That was kind of my take on event streaming platforms. Hopefully that was fun. That was interesting. I'm going to now hand over to Murali to talk a little bit on the benchmarking on Kafka and the work on that what Intel is doing to improve the Kafka performance in the open source upstream.
Can you guys see my screen? Okay, thanks, Heikki, and for the good introduction on event streaming. And from Intel, we've been working closely with Heikki and Aiven to make sure that a lot of the optimizations we do for open source projects, which they are providing as a service, gets the best possible optimization, the best performance in Aiven Cloud. Um, so, so what you guys know Intel as a microprocessor company, but what do we do with software? So, in fact, we have more than 15,000 engineers working closely with ISVs and software providers. We primarily provide optimizations and expose our features like platform features through operating systems. We hold engineering relationships with almost most major ISVs to make sure that their code runs best on Intel and x86. And also this includes both commercial software, and we have a big presence on open source projects. And a lot of the work we do with Aiven is on the open source space, and I'm going to talk particularly about um, Kafka here, but we do other things. The big thing about Intel is it does optimization, the whole pipeline, starting from ingestion to processing to search to analytics to AI. So we have optimized the whole stack of the data pipeline, and we also have great tools, right? And so not only do we make sure that our platform features get exposed and get optimized on software, but we do have tools we to look into the telemetry and to be able to optimize your software to find bottlenecks to fix it. And recently we even acquired a tool called Granulate, and we have other tools, VTune, which can look into provide telemetry. As I said, we have more than 15,000 engineers, and we are pretty much heavily invested on software. Software is a vehicle through which all our platform features, performance get exposed. And we are the number one contributor to the Linux kernel, and we work with several open source projects. With example being TensorFlow, and in this case the OpenJDK, right? So we optimize Java quite a bit, and Kafka being developed on Java. OpenJDK is a way we expose a lot of the optimizations and make it easy for any user to just use the latest JDK version to get all our optimizations. So what is the impact with all of this work? As you see here on top is the OpenJDK that's much more relevant. Kafka has much better performance through using the latest OpenJDK, but we do have other higher order of magnitude improvements in other projects too, and a lot of focus on AI and databases, right? Search, you see it here. It's pretty much the whole analytics and AI pipeline has been a lot of focus for us recently. And one thing you can do with Kafka is just update to the latest JDK version, right? That should give you a lot of better performance and get all our optimizations on Kafka. So coming specifically, the next few slides, I'm going to talk about what specific work we have done with Kafka and some of the optimizations and performance numbers and some of the performance work we're doing with Aiven, right? What kind of performance we are seeing in some of the AWS instances. Um, Two big areas which we have focused on. Our latest uh, Intel processor, the third gen Xeon, is our Ice Lake, codenamed Ice Lake, and we've recently also launched the fourth gen Xeon, which is Sapphire Rapids earlier this year. But starting with Ice Lake, which is the third gen, there are optimizations on crypto acceleration. So when you see the Kafka architecture on the right, pretty much all data which gets sent from the producer to your brokers to your consumers, a lot of the data is encrypted for security, and we have optimized all the crypto algorithms which are used for this purpose. And we can offload that processing from the CPU to accelerators or specific processing units, and also given AVX 512 optimizations for that. And this is the test methodology. We picked AWS instances primarily for the broker, Kafka broker. We use different instances, and because that's the primary Kafka component or the server component for performance, and we have used producers to send data and consumers to consume it, and then looking at just the Kafka performance across different Intel Xeon generations. And then different JDK versions, as I told you, we get the software optimizations through JDK, and also some of the compression encryption optimizations we have in the software. How does it get exposed through the JDK layer? And we measure as Heikki pointed out, the throughput and latency as metrics to do that. So here is one, and particularly if you look at the second gen Xeon, which is the Cascade Lake, we've compared it to the latest third gen Xeon Ice Lake. As you see here, just by moving to Ice Lake, and which should be pretty much in a performance parity, but you out of the bat you get a 33% improvement on throughput and a 12% improvement in latency. So just the highlight here is primarily this is coming from some of the crypto instructions that are available in this processor generation, right? The third gen Xeon. Just by moving to that and using the JDK 11, you would be able to get that much performance improvement. And next thing here is we have benchmarked scaling of our instances, right? If that instance you're using for the Kafka broker, you're getting pegged on CPU, you go to the next higher instance, right? Like the extra large to 2 extra large to 4 extra large. What we're showing here is the almost linear scaling of improvement in Kafka performance. By picking the next higher instances, we're able to get much better performance in Kafka by and this depends on choosing the instance depends on your workload and your throughput and latency requirements. But what we have done on our stage is to get the maximum performance on the Intel instances you would choose. And here, since this is about software, as I said, Kafka, primarily our optimizations, most of our optimizations are exposed through JDK and the Open JDK version. And this shows that we have continuously invested in JDK optimizations going from 8 to 11 to now we are on 17, and we are also optimizations on JDK 19. But as you see here, the latest JDK versions always give you better performance on our latest Intel instances for Kafka. Okay, the last thing on the compression. So the different compression algorithms which Kafka supports, as you see here, gzip to Snappy to zstand, LZ4. This shows that what kind of performance you can get on our Intel 3rd Gen Xeon processor with the different compression algorithms. And as you see here, there's a good performance improvement with Snappy, Z Standard, and LZ4 on Intel 3rd Gen Xeon. And better yet, we have what we call Intel performance primitives. So these, the previous slide showed the compression out of the bat, but if you want to get even better performance, we have Intel performance primitives and ISAP, which can even get you better performance. So that's what this shows that, hey, by going to 3rd Gen Xeon, you get a 15% improvement. But if you optimize with Intel performance primitives and ISAP, you get up to like 1.47x better performance. So always the Intel optimizations are going to give you a scale of better performance. So in summary, as you're evaluating Kafka as a workload and looking at the cloud and Intel, our suggestion here is to always use the latest Gen Xeon processors because we are constantly exposing features which benefits of both data pipeline and Kafka in particular. And so in this case, currently the 3rd Gen Xeon is available widely in the cloud, and the 4th Gen Xeon is just starting and should be available in the second half of the year. So the 3rd Gen Xeon and the 4th Gen Xeon are important. And then as you're getting out of performance on your CPU, look into higher core count, right? Go from extra large to 2 extra large to 4 extra large, and almost all of these instances have been optimized for in Intel for a best performance. So go to higher instances, use the latest JDK. I think currently Kafka is on JDK 11 and 17, and we are working with to optimize 19 too, but move to the latest versions of the JDK, and also use some of the hardware features on encryption and decryption. I've shown the improvements. Use that to use the right algorithms on the Intel instances. To the future, we have the 4th Gen Xeon, so we just don't stop. We continue optimizing. As I said, we have been working with the open source community and on more improvements. And with 4th Gen Xeon Sapphire Rapids, we've got a wide variety of accelerators. QAT is an accelerator for compression, and we have much more accelerators called in-memory IAA. And so we are using those accelerators to bring orders of magnitude performance. And as I said, Intel recently acquired a company called Granulate, which is optimizes Kafka. You just need to install it. It will learn it, uses AI algorithms, and optimize it on the fly on your production instances. So Granulate could be a version with which you could get like 25-30% extra improvement on top of what we've been providing with our software and hardware. The That's my last slide. And thanks for listening. And we'll open it up for questions.
All righty. Man, a lot of good information there. So thank you so much, Heikki and Murali. Looks like we did have a few questions come in here. All right, let's see. Yeah, okay. And then I guess so we'll just kind of pitch this to both of you guys and y'all can kind of fight over who's going to answer, okay? So the first one is going to be, how often should I reevaluate my decision of event streaming platforms?
Maybe I'll go at that first. When you are essentially facing challenges that the current solution doesn't solve, I think that will be quite the most natural place. Of course, it's good to evaluate things and try out things and see if there are kind of new technologies or solutions that are better fit. But there's always this cost of kind of transformation your workloads between different technologies. So I wouldn't spend too much investment before having some good reasons doing that. That said, I would have to say that event streaming, I think it's a little bit of a paradigm. And once you move into that model where you're considering acting on single events or kind of this endless stream of events and you lay out your architectures in that manner, then it is much easier to do transitioning, say, from AWS Kinesis to Apache Kafka to Apache Pulsar or vice versa, because I think there's a lot into the model on how do we architect based on the event streaming architecture paradigm in general.
Yeah, real-time streaming has been catching up quite a bit, right? We started with PubSub and queuing technologies and then ingestion. Now real-time streaming is becoming a big one, and there are a lot of new projects coming, but um, it all depends on the customer requirements and kind of keeping a tab on the open source projects. There's been a lot of committing and features like multi-region replication, tiered storage, a lot of it coming. So you kind of keep a tab on that because a lot of this could save costs on your deployment. So keep a tab on that. That should be useful.
Yeah, thanks. Good to know. Okay, another question here. When does a proprietary solution make sense?
I'm a little bit biased because we offer especially open source technology, and we have a big belief that open source gives organizations and individuals the business agility and business continuity that they benefit. But I would say that there is always kind of there will be always niches where proprietary solutions are kind of created and they fulfill a need that no one caters to, or even create a new market that is not catered by open source. I think in those cases it's perfectly kind of valid reason if there's a solution that solves a business need. But at the same time, I think open source in general has very good qualities. It has this business agility, business continuity promise that you can keep on control of your own processing activities, no matter what happens to a single vendor or license. And at the same time, I also think that there's a lot of innovation happening in open source space. If we look at some of the technologies, or if we look at Apache Kafka, for example, how many companies and how many individuals are contributing to the technologies because they use it themselves. They need something more that is still missing from there. Or looking on Intel's investment into making sure that we can run it as efficiently as possible. So the open source solutions tend to have a very good technology trajectory in my mind.
So I think from an Intel standpoint, as I showed how much we are invested in software, right? And this is split across both commercial software and open source. But open source particularly is very important for us because we can time to market. We have more flexibility in bringing our hardware features exposed quicker. through open source projects, and this is of all the Apache projects, right? Kafka is a very important one for us, but we do work on the search side, and as I said, the whole analytics pipeline, and even in open source. Some we're looking for partners, right? In many cases, we are top contributors, but we're looking to Aiven to be our top partner there to push some of our latest optimizations. Say we optimize the QAT accelerator, right, and our 4th-gen Xeon, and bring some code snippet and where to open source. And if we are not able to get into the right Apache mainstream, but we would want to get it exposed, Avon would be our place to go to kind of work closely together with software partners to ultimately expose all the goodness in our hardware through software, so and reach as much people as possible. That's what open source brings us.
Yeah, yeah. Open source is really helpful because oftentimes, somebody else has already done 75% of your work, right? So, it really helps with the agility and the time to market. So definitely good to check that out. Kind of on that note or that vein, when does like a self-managed solution make sense, right? The proprietary versus and then self-managed. When does that make sense?
Again, I have to say I'm quite biased here, but I think what's more important is, and that goes with the kind of same thing that we want to say for open source. I think it's important that you have the ability to do so. So if there would be any business reasons mandating that, say, maybe there's a regulatory change, or that just then the scale of the operation grows so much that it starts to make sense that we want to hire a full team around it and make sure that we can cover 24/7 operations around the world and around the clock. When that starts to make sense, maybe it makes sense to run these things in house. But at the same time, I think I would recommend everyone to consider to utilize managed services as much as possible. Not because we are selling that service, but it's also about productivity and being able to focus your resources on what really matters. So if we look at our customers, for example, it's not their benefit to spend their hard to find talent on running infrastructure and making kind of doing operational things and ensuring that security software patches are deployed, or that if there's a virtual machine in cloud goes missing, replacing that and making kind of returning the clusters and into redundancy as was specified. It's much more important that they can focus on the applications that can use this infrastructure to make a kind of business differentiating work, making something that is kind of business critical going forward.
So I think the Intel standpoint here is, and we do work with companies who do on-prem to private cloud to hybrid, public and multi-cloud now, right? And a lot of the offerings are even multi-cloud. What we see here is Kafka being a fundamental workload is pretty much used by a lot of the top 500 companies, right? And then and by managing yourself, or you managing the whole deployment, right? The data volume goes up and things go down, the resilience and reliability, availability, all those factors Heikki talked about. By going to a service, you're pretty much focusing on your business and leaving all of that to the provider to be able to take care, right? So you're focused on what you can control and business, and leave the whole management and the infrastructure to the service provider. So that um, and that makes a big difference.
Yeah, yeah. Actually, sort of kind of had a follow-up question on that note from the audience as well. When should I go for a self-managed versus hosted or managed Kafka service? And maybe what should I look out for? Any thoughts?
I think this would be my answer would be the same. I would, unless you have a scale where it makes sense to operate things, or have a devoted team that runs and operates those services, I would definitely recommend utilizing managed service provider. And for Apache Kafka, I think there's also a lot of not opportunities, but a lot of options. There's a lot of vendors that offer the same service. So kind of it's you have the option on choosing and then revisiting that decision later if need be. I think it comes down to again using that talent that is hard to find to the best value for the organization. And this goes into whether it's Kafka, whether it's PostgreSDB, or whether it's ClickHouse for data warehousing, whether it's OpenSearch. Running and managing them requires time and talent. And kind of I would use that time and talent to focus on something kind of business differentiating.
Okay. Are there any sort of like, specific things or offerings or something from these service providers that I should look out for that would kind of give me an advantage over another one? I mean, is there a specific thing that I really need to make sure I have from the service provider, or something I should look out for, avoid?
Yeah, maybe if I continue there, I think it makes a good, at least a good checklist to make sure that the provider complies with all the regulatory compliance that your business is working on it, or information security compliance, that they do, that the provider does kind of operate in a manner that is a good match for your use case and for your data. That will be definitely a first-hand experience. Then it comes into availability of tooling, how easy it is to deploy, how easy it is to integrate that service, what kind of SLA the provider can provide, and if they have a kind of actual observed SLAs to back those claims up and so forth. But it's good to also evaluate providers, especially when we start to think about or start to talk about, say, Apache Kafka as a technology, for example. Then typically you'd expect that you get the endpoint, you can run your applications on the same setup regardless of the provider. So it should be fairly easy to evaluate multiple providers as well and see whoever fits or is the best match, both from perhaps cost perspective, but both also from the features and functionality that makes your applications and your development teams productive.
Murali, any thoughts you want to add to that, or?
Yeah, I said, as Intel, we have innovated throughout on the data center side, from data center to cloud to edge. We're available in all the major public cloud and in all clouds. And as I said, we're continuously optimizing a lot of the open source projects like Kafka Search or databases. And our only thing is be on Intel, be on the latest instances, use the latest version of the software, and get the best improvements. Right? As I said, it's the gen to gen improvements are only like 20-30% from the hardware. A lot of the magic happens in software, where we have given like 4x to 5x improvements by working closely with software vendors and open source projects. So the take advantage of it, and definitely we're bringing it through Aiven Cloud, and that's part of this initiative. We're working with Heikki to make sure that using Aiven, you get the best performance on Intel.
Cool, thank you, Dad. It kind of end on kind of a more fun question, I guess. How can maybe a college student or somebody who's really early in their career contribute or begin contributing to open source? Like, what are some of the best ways? What are some of the easiest ways that they could do that?
So if I go first, I think open source contributions include not only code, but say all points of documentation, all kind of public presentations, if you will. If you're new to open source want to contribute, maybe write a blog post out of the journey on taking this technology into use, or then find something that is missing from documentation to contribute, or then look at the bug tracker, maybe find one item that is bothering someone and then fix. I think it's about getting started, and then kind of I think it's that more than anything, it's about that one thing to be part of the community, one thing to also share your work with others, and actively doing something good for the benefit of the whole community. So maybe just good luck, and yeah, maybe hope that you get started.
Yeah, if I could follow on maybe a shameless plug there, Heikki was talking about documenting and things like that, writing a blog post, and then DZone's a great place to publish those things, right? So, I mean, you could document your journey, document your experiences, and then post it on DZone and share it with the wider community. So it's kind of a great place to start, I think. Murali, do you have any other suggestions or any ways they can kind of start help contributing to open source?
Yeah, open source is democratized software, right? And one thing I could say is we have interns all the time, and some of the projects we put directly in some of our software groups is getting tried, like Heikki said, to start contributing in one particular area or feature we are using, how to kind of expose that, right? And things like that, and that's a quick way to contribute and make an impact. So maybe an internship at Intel would be a route to it.
Yeah, thanks for sharing. I think ultimately, as Heikki said, the point of open source is just wanting to be involved, right? Any contributions are helpful, and just get involved and join the community. So I've heard someone say one time, developers are a tribe. Like they're very close knit and they're very want to help each other. So just be a part. So that's going to do it for us. We're coming close to the time here. And I just want to say thank you so much, Heikki and Murali, for joining us. This is really great information. So really appreciate you guys. If anyone else does have any further questions, you'll be able to find their contact information on our events page. You can just navigate to this webinar and you'll be able to find it there. So yeah, check out our website, dzone.com/events. You'll see this one there. You'll see all the other events that we mentioned at the top. So head over there and see what we've got for you. Thank you, everyone, for watching us or watching this and joining us today. I hope you got something out of it and maybe learned something. Good luck to everyone and have a wonderful weekend. And we'll see everyone next time. Thank you so much.
Thank you, guys.
Thank you.